Hello, I'm Lisa Marie Shillito from Newcastle University. I'm very sorry that I can't be with you today in Barcelona, but thanks to the wonders of modern technology, I've been able to record my presentation. And actually, I am following along on Twitter, for those of you who use Twitter, so I will be available virtually for any questions afterwards as well. So I'm going to talk to you today about a new project that we've been doing at Catalhoyuk. I say it's new, but it's actually based on over a decade of developing this idea of a multi-proxy approach to research questions at Catalhoyuk. So it's very much a kind of ongoing research program. But this particular part of it is looking at the relationship between people and the environment in the broader sense, particularly focusing on the use of fuels and the relationship between fuel use and respiratory health in prehistory. So it's actually part of a slightly larger project, so I don't have time to kind of talk about all of it today, but it's part of this kind of wider project looking at the impact of living in a settled environment on health in prehistory, particularly trying to use or trying to develop non-skeletal health indicators and integrating these approaches with traditional osteoarchaeological methods. So there are two strands to this project. There is a strand looking at sanitation and gastrointestinal health using things like coprolites and parasites, etc., which I don't have time to talk about today. And then the strand that we'll be looking at today, which is looking at biofuels and respiratory health. And aside from the question of health, these different strands of the project are linked by this idea of a multi-proxy approach and bringing together different geoarchaeological methods with more traditional approaches from archaeobotany and bioarchaeology, and how we can use all of these different methods together to address common research questions. So this idea of a multi-proxy approach to reconstructing fuel use, it's something that I think most of us here in this session today are very familiar with. But traditionally in archaeology, the reconstruction of fuel use has been based very much on the analysis of wood charcoal. It's something that's relatively easy to see in the field and can be recovered from sieving and flotation. But obviously the process of burning, as we know, produces a whole range of byproducts, including inorganic residues, i.e. ash deposits, and also organic residues, so invisible chemical signatures as well. So a lot of the work that the geoarchaeology team at Catalhoyuk have been doing over the years has been based around trying to integrate different methods for analysing kind of the non-wood fuel component of the archaeological record. And here on the right, you can see just some examples of the beautiful deposits we have at Catalhoyuk. We have fantastically well-preserved hearth deposits. And I think the bottom picture really illustrates the importance of looking at more than just wood charcoal. So this is an outdoor bonfire deposit at Catalhoyuk, and you can see the little kind of black inclusions there. There's a lot of wood charcoal in there. But actually, a huge proportion of the byproducts of burning here are actually ash residues and charred sediments. So these brown deposits that you can see at the bottom, that's the base of the fire. This kind of charred rubified sediment is actually full of organic residues that are associated with burning as well. So the idea of a multi-proxy approach to reconstructing fuel use is based on bringing together traditional wood charcoal analysis with methods for characterising ash deposits and also charred sediment biomarkers as well. And just to give you an example of the sorts of things we see when we apply these approaches at Catalhoyuk, again, there's been a huge amount of work being done at the site on different deposits, both from within buildings, looking at hearths and ovens, and from external areas, looking at bonfires and fire spots. And what we see is that, first of all, ash is preserved very, very well at Catalhoyuk. But when we look at it under the microscope, we can see a huge degree of variability in the types of materials that are actually being used as fuel. So this is a combination of geochemical characterization and microscopic analysis to actually characterize the types of fuels on the basis of the ash. So what we see at Catalhoyuk is that some deposits, for example, this bonfire deposit you can see here, is composed of a huge proportion of silica-rich ash and phytoliths, things like grasses and reeds, and also quite a high proportion of animal dung ash in there as well. Whereas other deposits, for example, things that we might see within a building, within a hearth, might be more mixed, consisting of ash from wood burning, for example, along with charcoal as well. So I think this really illustrates the importance of geoarchaeological approaches, particularly when non-wood fuels have been used. Things like animal dung, reeds and grasses, cereal byproducts. These are all materials which are relatively lightweight and actually are transformed to ash very rapidly on burning. So they won't preserve, or very rarely preserve, as part of the macro charcoal record. So it's very important that we actually use these other types of methods to try and get a better sense of the proportions of wood versus non-wood fuels in the archaeological record. And as I said, at Catalhoyuk, what we're beginning to see after many years of applying these methods to different contexts is that, as well as having quite a variable pattern of wood exploitation over time, we also see a degree of variability in the non-wood fuels as well, particularly indoor versus outdoor fuel deposits, for example, and things like reeds and animal dung are very significant parts of the fuel record. So just to explain a little bit about the current project, when I joined Newcastle University back in 2015, I was kind of looking around, seeing what sorts of other research were going on in the university, and I came across this term biofuels, and this is a term that's used predominantly in modern context as an alternative to fossil fuels. This idea that of these sustainable biomass and biofuels as alternatives to what we know are very fuels that are very bad for the environment, that is fossil fuels. And this I found really interesting, because all of the materials that we actually see at Catalhoyuk and elsewhere in the archaeological record, things like animal dung, Phragmites reeds, etc., these are all being promoted under this banner of biofuels in modern contexts. And the idea behind this is that they're renewable, they're sustainable, the environmental impact is less than fossil fuel burning, although that's something that could be debated. But actually the health impacts of burning these sorts of materials are just as problematic as burning fossil fuels, particularly in Turkey, for example, in rural contexts where these sorts of materials are actually burnt within enclosed spaces with poor ventilation. It's known in modern context to have quite significant negative impacts on people's respiratory health. So this got me thinking, from an archaeological perspective, this is really interesting, because at Catalhoyuk and at other types of settlements in this region, we have this very dense agglomerated settlement pattern. We know that people are burning large quantities of these so-called biofuels. This is very likely to have had an impact on the health of our prehistoric inhabitants as well. So I thought, can we apply these methods that are used in modern contexts to our settlements? So in collaboration with colleagues from civil engineering, in 2017, we actually conducted a series of experiments, first of all to assess the feasibility of applying these modern tools, so air quality monitoring methods and computational fluid dynamics, whether we could apply these to an archaeological settlement, and what types of results we might get through burning different types of fuel within a typical Neolithic building. And we're very lucky at Catalhoyuk in that we have these wonderful reconstructed Neolithic buildings where we can actually conduct these sorts of experiments. So over the period of about a week, we conducted a number of burning experiments, focusing particularly on animal dung and oak wood, burning these fuels within the experimental houses for set periods of time, and monitoring the emissions that were actually given off during the burning process. So there's a whole range of different emissions that you can actually measure using these methods. For this particular pilot study, we focused on something called PM 2.5. So that's a particulate matter of 2.5 microns or less, using various types of air monitoring equipment. So the results of these experiments are really quite interesting. I think, both from the kind of the perspective of modern fuel burning, but also from the perspective of the archaeological record as well. So here on the left is an example of one of the cow dung burning experiments, and on the right we have the oak wood burning. Just to explain what we're looking at, along the bottom axis we have time, so the duration of the burning, and on the vertical axis we have the levels of particulate matter that were produced during these burning episodes. And what is really quite shocking in some ways is the peak values of PM2.5 that were recorded were in excess of 18,000 micrograms per meters cubed. So just as a comparison, you can see here the World Health Organization's guideline safe level is an average of 25 micrograms per meters cubed over a 24-hour period. So the levels that we were recording in these reconstructed buildings at Catalhoyuk were many orders of magnitude higher than the guideline safe levels for these sorts of emissions. And this kind of makes sense when we think about the architecture at Catalhoyuk. We have these very distinctive buildings with no doors, with no windows, that were just accessed via this quite small hole within the roof. So quite poor ventilation and lack of airflow within these buildings. So in some ways this result is not so surprising, but the actual levels of emissions that are being measured kind of really bring home, I guess, if you like, the levels of pollution that people are exposed to from living within this early settlement environment. Just to point out some of the kind of differences between the two different types of fuel. This is something we still need to explore further. We can see there are differences in the patterns of emissions as well. So with the cow dung, we see it takes a little bit longer to reach the maximum levels of emissions, but then it remains fairly high and consistent over a longer period of time, and then drops off relatively rapidly after a few hours. Whereas with the wood burning, what we see is a very, very rapid increase to the maximum levels, followed by quite a rapid drop off as well, and then they stay lower but still very, very high compared to safe levels, and then tail off towards the end. We do see this secondary peak in the oak wood emissions, and this is probably to do with something like an influx of wind or something through the roof hatch. So the emissions are affected to an extent by changing conditions within the microenvironment as well. But in terms of the overall pattern, these observations actually fit with other experimental work that suggests that dung in general tends to burn much more slowly and evenly than wood, and that's something that we're seeing here in terms of the pattern of emission levels as well. So as well as the actual monitoring of emissions during the burning process, we also collected samples of the ash deposits that were left after the burning experiments, just to get an assessment of the composition of these different experimentally burned fuels. We conducted scanning electron microscopy and elemental analysis on these deposits, and as expected from previous experimental work and from archaeological analyses, the wood ash was dominated by calcite, whereas the dung ash is dominated by silica. And this is because dung contains, in this region, contains large quantities of phytoliths from the cows grazing on grasses in particular. And we can actually see that in the SEM as well, these digested plant tissues as well. So again, just thinking at this from the health perspective, the actual composition of the fuel is quite important. Although both types of fuel release large volumes of particulate matter, which are very bad for the respiratory health, the composition of the emissions can exaggerate the effects, if you like. So silica in particular is linked to a condition called silicosis, which is an irreversible deterioration of the lungs, often associated with miners, for example, or in Turkey in modern contexts with denim sandblasting for production of things like jeans, for example, and is known to be the inhalation of silica particles in particular is known to be particularly bad for respiratory health and often leading to fatalities as well. So that's where we are at the moment. We're currently, as I said, this is a pilot study. We're actually in the process of doing a lot of the analysis at the moment. What we're hoping to do next is to actually integrate the analysis of the ash archive at Catalhoyuk. So we have over 25 years worth of material collected from hearths within buildings and from outdoor bonfire deposits. And we're in the process of characterising these deposits and integrating that with the existing wood charcoal record to try and understand the relative proportions of wood versus non-wood fuel and how that changed over time and how that varied according to different contexts within the settlement, different parts of the settlement, indoor versus outdoor, etc. In terms of the computational fluid dynamics, what we want to do now is to scale the analysis from the level of an individual building and apply that to the entire settlement. So again, at Catalhoyuk, we're very lucky in that we've got this fantastic architectural record and an open access GIS. And so we can actually map the exposure to pollutants within a particular stratigraphic level of the settlement and then map how that changed over time as the settlement density changes. So at Catalhoyuk, we have this quite distinctive change in the settlement pattern. In the very lowest levels, it's a very dense agglomeration of buildings. Towards the later levels of occupation, it becomes a bit more open and dispersed and begin to see larger kind of open areas within the buildings. So we can actually explore the impact, if you like, of this changing settlement density on the levels of exposure that people would have been subject to from burning these different types of fuels in different locations. And the next stage, following the computational fluid dynamics, is obviously to then integrate this with the osteoarchaeological record. So that is the end goal, if you like, of what we want to achieve with this multi-proxy geoarchaeological approach, is to then bring that together with osteoarchaeological analysis. So can we actually predict exposure in the osteoarchaeological record? So with our computational fluid dynamics, we can hypothesize that at various stratigraphic levels, we've had certain levels of respiratory pollution that people were exposed to. Can we then go and look at the human remains archive and detect this within the human skeletons? So again, Catalhoyuk's a great case study for this because we have over 700 skeletons available within the archive, which we can interrogate not just for physical indicators, so things like lesions on the skeleton associated with respiratory disease, but we can also look at biochemical indicators, so actual preservation of things like bacterial lipids within the skeleton that might be present even when physical indicators are not, for example. And following that, what we hope to do is to kind of map the changing exposure to these respiratory pollutants over time in relation to settlement density and settlement patterns, but also to explore whether we can see links between levels of the exposure to pollutants and demographic factors. So obviously focusing on age and sex of the inhabitants. And this is going to be, I think, really interesting from the perspective of understanding social inequality or social equality in the Neolithic, whether we have differences in the level of exposure associated with these different demographic groups. So that's it from me. I'd just like to say thank you to the people there on the left, particularly emphasising the whole of the team at Catalhoyuk. Obviously, we're doing kind of applying these new and exciting methods at the site, but we couldn't do any of it if we didn't have such a fantastic archive of data at the site and an archive of samples to work with. So anyone who's worked at the site over the past 25 years and has contributed to that archive, we very much like to thank those people. And as I said at the beginning, I'm following along on Twitter, so if anyone has any questions, please do send me a tweet. Thank you very much.